We previously discussed atoms being the smallest part of an element, but what we don't know is that, with the exception of the noble gases, helium, neon, argon, krypton, xenon, and radon, most elements actually do exist in a molecular form instead of an atom form. The atoms exist, but they don't exist by themselves unattached. A molecule is an assembly of two or more atoms that are tightly bound together, and we know that from earlier studies, probably in junior high and middle school. Now, what we don't know is that many of the elements that we find in nature are found in a molecular form, as I just said. It means they're found as two or more atoms of the same thing joined together. For example, oxygen is found in nature as O2. There are 7 elements that we find in pairs just like oxygen. We call those the diatomic molecules. Diatomic, the prefix di means two atom molecules. The 7 others are nitrogen, oxygen, chlorine, fluorine, bromine, iodine, and hydrogen are our 7 diatomic elements. Now, they're easy to remember because if you look at a periodic table, they start with element number 7, nitrogen, and they are in the shape of a 7 going over and down the families, with the exception of hydrogen. So there are 7 of them starting with element number 7 in the shape of a 7. Now, another expression we use commonly to represent them is O-B Finch. O for oxygen, B for bromine, F for fluorine, I for iodine, N for nitrogen, C for chlorine, and H for hydrogen. Those expressions are used to represent the diatomic molecules. Now, what does it mean for those to be diatomic? It means that in nature they're not found by themselves. I always use the analogy like girls going to the bathroom. They're never found alone. They're always in pairs. So, when we have one of these elements and we're found in nature in a chemical reaction, for example, we must write them as O2 or N2 or Cl2. So in chemical reactions, they must be written that way. They cannot be written simply as oxygen. Now, neutral atoms have no overall charge because their number of protons, number of electrons are equal to one another. Sometimes elements can lose or gain electrons to become what we call an ion. An ion is an atom that has lost or gained an electron and thereby has a charge to it. A cation is an ion that has become positively charged by losing electrons. It sounds confusing that you're losing electrons to become positive, but if you think about the charge of an electron as being negative, you're losing negative charges to have more positive charges in the nucleus. For example, sodium has normally 11 protons in its nucleus, which are positively charged, and 11 electrons in its outer energy levels, which are negatively charged. When sodium ionizes, it loses an electron, and as a result, it now only has 11 protons in its nucleus still, but only 10 electrons are in the outer energy levels, thereby giving it a positive 1 charge. So ions that lose electrons tend to become positively charged. They can be positive 1, positive 2, positive 3. What we find is that cations are ions with a positive charge. The way I always remembered that is if you look at the word cation, I always looked at it as it represents that you see a, and if you think of the T as a plus sign, positive ion. Okay, so again, you see a positive ion, cation. Metals tend to become cations. Metals tend to lose electrons to become positively charged. Now, nonmetals tend to gain electrons, thereby becoming what we call an anion. An anion is an ion that has become negatively charged, or a negative ion. That's the way I remember what it is. So an anion is an ion with a negative charge. Now, how do nonmetals become anions? Let's look at chlorine as an example. Chlorine has 17 protons and 17 electrons in a neutral atom of chlorine, told to us from the atomic number. When chlorine undergoes reactions, it tends to gain an electron, taking on an extra electron. Now it has 18 electrons and only 17 protons. As a result, it has one more negative charge than it does positive charge, making it a negative 1 charge overall. We call that an anion. Negative 1, negative 2, negative 3 in charge, depending on how many electrons are gained or lost. In addition to ions like sodium and chlorine, we have what are called polyatomic ions. Polyatomic ions are those ions given to you in the list earlier in this chapter that have more than one element combined together molecularly, but as a result, they end up having an overall charge to them. For example, nitrates and sulfates are two of the most common ones we hear about. A nitrate ion is an ion that has nitrogen and 3 oxygens joined together, but as a result of the combination, they end up having a -1 overall charge to them. Sulfate is sulfur with 4 oxygens joined together, and as a result, it has a -2 charge to them. You are responsible, or you should take the time to learn not only the names and formulas for these ions on the list that you were given at the beginning of chapter 2 with the notes, but you should also take the time to learn the charges as well, so that you know nitrate is NO3 with a -1 charge. All right, this has been talking about ions, positive and negative. Again, as a recap, most elements that exist in nature are in molecular form. That means they are combined in pairs. The most common ones are what we call the diatomic molecules, which means they are in pairs. Some elements lose or gain electrons to become what we call an ion. An ion is an element with a charge. A cation is when an ion has lost an electron to become positively charged. Again, metals tend to do that. An anion is an atom that has tended to gain an electron and has become negatively charged, and non-metals tend to do that. And polyatomic ions, is the prefix poly means many, atom, ions are ions that have several elements joined together, and as a result, they have a charge to them.